Okay, so last time we left off with the ball bouncing around. Bouncing around our little window, and that was all well and good. For our simulation, because we want to make it similar to the ones that we described before, we're going to have a couple of hundred of these balls flying around. So let's have a look about how we could go about making a second one. So currently what we've got going on, we've got X location, Y location of one particular ball, and then a velocity X and velocity Y of one particular ball as well. So if we wanted a second ball, we're going to need all of this information again, but for ball number 2. Okay, we're going to start them in different location so that we can definitely see that there are 2 different balls. Let's go for 40 instead. 40 by 40. And different velocity, but because I haven't actually moved the new ball yet, ball number 2, we should see that if I run it now, nothing happens at all. Sorry, I shouldn't run it now. There's just one ball at the moment. We've got the ability to have 2, but I've not coded that yet. Hold on. Yeah, so we've still got one ball. Yeah, when it comes to painting, we're also going to be painting at location X2 and Y2 as well. So we're drawing one circle there and one circle at location X2, Y2. Let's draw it again. Here we go. So we've got the one ball that we had before, and that's moving just as it did before, and we were able to draw the second one. So that meant that we had to copy over all of this information, and we had to double the amount of lines to draw a circle, because we had to have another additional line here for the second circle, and we've not even taken into account moving the ball. We've not done the moving of the second ball. It would just mean copying all of this and kind of having different identifier names. I'm just going to stick 2 on the end of almost everything. And run it again. So it should work because we've got virtually the same code for both balls now. Yeah, so we see that we've got the 2 balls on the screen moving independently and still got collision going on. But I've almost had to double all of my code in order to get this working, to get a second ball. If I got a third one, I have to triple what I originally had. And if I wanted to get a couple of hundred, that's a lot more lines of code all of a sudden that I'm having to do. So that's why we've been learning more recently about object-oriented programming. So that instead of us having to code every single individual item, we can group and create a modular structure of I don't know, I haven't thought of a name for this. Yeah, a person in our simulation. So that we can make more productive use of our time. So we can make one class of a person, and then we can make hundreds of thousands of them really quickly and really easily. So that's what we're going to do next. I'm going to undo the code changes we made, because we don't want to code in that fashion. Okay, so we're back to just being a single ball here. What I'm going to do to help me do this, I'm going to make a class. So I've right clicked on my project file, add new item. It's going to be a class, and I'm going to decide that it's going to be called person, because we're going to have a people in our simulation. So a class would be a single person. And I'm going to think, well, before I start moving things, I'm going to think about what a person has. Well, currently, our person has an X and a Y position. So I'm going to start moving those over to my person class. Now remember, classes, we're going to have properties and methods. So I'm going to just make a comment here. So this is where I'm going to put my properties. So I'm going to have an X and a Y position, and I'm going to just leave them completely blank at the moment. I'm not going to assign them any values. And just to make it a little bit shorter on code, I'm just going to declare two variables on the one line. So by putting a comma in there, I'm saying that int X, int Y, I'm declaring both of them at the same time. It's exactly the same as doing it over two lines, except you're saving a line. Okay, so we've got two integers there for X and Y. We also had the velocities as well. So yeah, I'm going to declare those as well. Velocity X and velocity Y. So we've got all of that. Anything else that we need? Now I'm going to have our actual painting of the ball. Yeah, I think that's it for properties now. No, I said I did want to have, I did want to avoid using just random numbers in here. So for the height and the width, I wanted to create a variable. So I'm going to do that right now. Height, and spell it properly, height and width. So all my properties appear at the moment to just be integers. So this person's just got an X and a Y position, a velocity X, a velocity Y, a height and a width. And that's all I've got for now. And then we need some methods or the behaviors of this class. So the methods. So one of those methods is going to be move ball. So we're going to copy what we had before. Right there. I'm going to copy that. I'm just going to move invalidated back across to the form, but put it inside of timer tick. So we've got one method so far, and because we're now in the class person, I'm going to rename it as well. I'm going to call it move person, just to make sure it makes a bit more sense. And because we're in the person class now and not the forms class, not form 1 class, we don't have access to client size anymore. We don't have access to that anymore. So we want to be able to get what that client size is. Now client size dot height, it's just an integer. So what I'm going to do instead of client size dot width, I'm just going to write width, and instead of client size dot height, I'm going to write height. No, I'm not, because we've got height and width already in here. I'm going to call it form width and form height. Now they don't exist in here, so what I'm going to do is pass them through. Form width int form height. And pass them through as parameters. And that has got no red lines, that's all good. So we've got one method there, move person. Almost identical to what we had before. Almost identical to what we had before. Is there anything else? We want to be able to paint as well. I'm going to not maybe call it paint in this. I'm going to call it draw. Private void draw person. Draw person. And in order to draw the person, I'm going to send in some graphics, because it's going to draw it onto the form. And call it graphics as well. Now that's coming up red because in this new class that we've made, it's not a form that we've created here. It's just a blank class. So when it's given me some nice library routines at the top, it's not got all of the ones that we had a moment ago on Form 1. It's not got system drawing, system Windows Forms, etc. So that's why it can't find graphics here, but it can find graphics here. And if you hover over it, it tells you what package it's part of, so which library it comes from. So that's from system.drawing. So there's two ways I could fix this red line. I could do using system.drawing. I could type that in and then it would find it, or I can get Visual Studio to help me out a bit and do it for me. So we've got that little light bulb again, and the first suggestion is exactly what I wanted. So it couldn't find graphics. Are you missing a reference? Yes, I'm missing that reference. So I click on it and it goes and puts it in. And now this has no longer got a red line under it, and it's blue, showing me that it actually can find it. The fact that this isn't greyed out means that we've actually got a reference to something from that library in here. So later on, if any of these are still grey, I don't actually need those references, so I could get rid of them. If I do use any of them, they will turn into a not greyed out colour like system drawing is there. And then draw person. Well, looking at what we had before, we're going to have to figure out what colour it is and then draw the shape. Okay, and this has given me a clue as to what additional properties I will need. I'm going to need to know what colour this person is, because later on we're going to use colour to help us determine whether this person is sick, whether this person is healthy, whether they are immune to the disease now, to the virus, sorry. So I'm going to have another property here for colour. And you notice here that colour is spelt the American way. So for our identifying name, I'm gonna spell it the English way. So it's nice to use. And by default, we could set a default colour. No, I'm not going to set a default colour yet. So instead of blue being there, I'm going to just set it as colour. Then if we change the property of this person, it will change the colour. and down here I no longer want to use 10 and 10. I want width and height. I want width and height in there. Okay. Based on what we had before, I can't really think of any other methods that our person class will have for now. But I would like to create a constructor. So it's kind of a special type of method, a constructor. And what a constructor will do, it will allow us to create a person. So a constructor has the same name as the class. It doesn't have void or a return type. It can have some attributes that you set initially. You can pass in some values, just like you can with another subroutine. But this is only going to be used when we create an instance of a class. So this is known as a constructor. If we didn't actually make this constructor, there would be a default one. So when we made a new person, and we would have had to type person, give it an identifier equals new person. It would have essentially just made a blank person. So even without having a constructor, there is a default one, and it essentially does this, which is nothing. Our default constructor, we're going to give it just some initial values, and what would be good to do is have a random number generator in order to randomize where these people are and to randomize their initial velocities. So I'm going to declare a random number generator. Static random. So there's a random number generator as well. The reason for me saying static is that I don't want a new instance of this being made every single person I make. Remember, we're going to be making a few hundred of these people, and if we made a new instance of random for each one of those 100, it doesn't actually generate a new random number, because it will be doing this so quickly. It will use the system time at that point as a seed value, and it would get the exact same random numbers appearing again and again and again. By making it static, we're not making a separate instance. So every time we use random, we should get a different value, and we should see that when we make hundreds of people, they will sort of appear random across the form. So our default person is going to have an X value, which will be random dot next. And again, what position X we want randomly, well, really it depends on what the form's doing. Now, however wide the form is, we want people to be able to spawn all the way across that X and Y. So I think I'm going to need to pass in the width and the height of the form, so that I can choose a random location within that width and within that height. For some reason we're going slow and crashing a little bit, not responding. Okay, we're back. So I'm gonna pass the width and the height of the form when I create a person to make sure that I'm creating an exposition within the form. I'm also going to establish what the height and the width of a person is here. So I'm going to go with 10, 10 equals 10. And when we have a random x, we want it to go all the way up until the width of the form minus the width of the actual person, because we don't want them half appearing off the screen. Okay, so that gives me a random number between 0 and, let's say, if the form was 200, 200 minus 10, so 190. So a random x value between 0 and 190, not including 190. We know it's not including because Visual Studio does describe it. Returns a random integer value that's within the specified range. So the minimum value, it's inclusive of the lower bound to be returned, but that means that it's exclusive of the upper bound, so it doesn't include the upper value. So it will always be at least one less than this. And we want a very similar thing for y. Random.next 0, so it can appear right at the top of the form that we're trying to make, and then the form height minus the height of our individual person to make sure no people are being created outside of the form itself. And then we want a velocity in x and a velocity in y to be generated. So velocity x, again random.next. Now I'm going to keep these numbers quite low because we don't want the velocity to be too high of these variety of things. We might change these to be floats later on, so we can have smaller increments between velocities. But for now we've got them as integers, so we're going to have our minimum value being 1 and our maximum value being 4 for x. And then for y, the same thing. And these are things that we can play around with later as to whether they fit or they don't fit, and we can mess about with the numbers to see how we want it to look, to get it to look how we want it to look. So we've got our class person there. We've got our properties, the data associated with the person. So we've got random number generator, x, y, velocity in x, velocity in y, a height and a width, and a colour. That's one thing I forgot to set. Good job I went through this. Colour equals colour, spelled the American way, dot, and we're going to initially, I think, set them as blue to start with. So setting them as blue. So yes, we get an x and a y position, a velocity in x and velocity in y, a height, a width, and a colour. And we create a person, we're going to send in the width and the height of the form. We set the default person to be 10 by 10. And we set its x coordinate that it's drawn at to be within 0 to the width of the form, and from the height from the top, from 0 all the way to potentially the bottom of the form, and then a random number for velocity in x, velocity in y, between 1 and 3. Remember, it's exclusive of the upper bound, so it'll be between 1 and 3 in the x coordinate and the y coordinate. So they're not going to move in a vastly different directions. They're all going to move in very similar directions, and the colour is going to be blue. So we're going to use this constructor whenever we create an instance of our class to create an actual object of person. Move person is one of the behaviors, so we're going to be able to move a person by calling this subroutine, and drawing a person, we're going to be able to draw a person by calling this subroutine. Okay. So back to our form. We saw how difficult it was to make two people before. We ended up having lots of lines of code. We don't need all of those definitions of x, y, vx, vy, and then when I did it earlier, x2, y2, vx2, vy2, etc. We don't need that anymore because we can create people from the person class. So I'll have P1, and I'll make another person. And you see here we're declaring them just like we're declaring them any other data type that we've had before. We're using the class person that we created over here to create these. And P2 we'll go for. In the initialize area, so the area where we initialize form 1, where we construct form 1, so that's the constructor for form 1, it's already created for you. We can do P1 equals new person, and we're going to pass in the form width. So we accessed it last time with client size dot width, so passing the width of the form and passing in the height of the form, and that constructs a new person. P1 here is the object, and using the keyword new, it's creating an instance of a class. In this case, it's an instance of the class person. And I'm going to do an identical thing for person number 2. And hopefully they won't be drawn in the same location, unless we're unlucky with the random number generator. We shouldn't be located in the same place. So that's creating two objects, two instances of classes. That's two examples of instantiation, creating instances of P1, person 1, and P2, person 2, both from the person class. When it comes to painting, well, P1 dot draw is what we're after, but we can't access that because, sillily, I left the access modifiers as private. There are three main access modifiers that you'll come across and deal with: private, public, and protected. If it's private, we can't access it from outside the class. So when I do P1 dot, it doesn't come up here. If I change these to being public, or if I change the draw person one at least to being public, and then show you again P1 dot, draw person appears. It is accessible from outside the class. And it wants us to pass in graphics. So we can draw that person, draw that circle. And we can do the same for person 2. Draw person, passing in as an argument to the parameter graphics. So both of these are calling this method in this class. But because they're calling them from different objects, they're calling them from different instances of this class. So P1's X and Y could be 70 and 100. So that when it calls the draw person, it's drawing at a position 70, 100. However, P2 can have a different instance of this data. So its X could be 50 and its Y could be 700. So that when it calls draw person, it's using the 15700 rather than what was there for person 1. There are different instances, different objects built from the same class. So that deals with the drawing. One more thing, we've got to deal with the moving. And again, it's the same thing. So we need P1 and we need to move person. Again, we can't see move person on this list. We know it's here. The reason we can't see it is because it's private. So we change it to public and we do P1 dot again. All of a sudden, it's accessible from outside the class. Again, it needs the form width and form height, so I'm just going to copy what we had earlier. And just the same as the draw person, although we're calling the same bit of code here, move person, because we're calling it from two different objects, they're going to react differently because it's going to be using the different attributes about that person. And in the timer tick, I kept the invalidate here because this is where the form is. And if we remember what the invalidate did, the invalidate caused the form to redraw. And when the form redraws, again back up here, when the form is painted, it's going to go and call this subroutine here, the paint. So every time the timer ticks, and I think I'm right in saying that it's every 100th of a second still, we move person 1, we move person 2, then we redraw. The redraw causes it to call paint ball, and then we draw person 1, we draw person 2. Okay, I've left an error in here just to show you this is a common error that occurs. So if you press start now, the program should compile and run, but we will end up with an error. And this is a common error that I want you to be aware of and understand what it means, especially when we're doing object-oriented programming. So it's an error that has appeared in our person class, and the error says object reference not set to an instance of an object. And what it's referring to is the random that we made. If we hover over it here, it says null, which means that we've not made an instance of this class. So when we declared random up here, random is a class itself. Random here is going to be our object. If we make an individual instance of this class, that error shouldn't occur again, hopefully. So we'll give it a run again. And by making an instance of the class, we shouldn't have an issue. And we don't. We've got the two balls moving around. You can see that they've started off at a different position and that this ball has clearly got a higher velocity. So the randomness appears to be working. and both balls still abide by the rules that we had before, making sure that they don't go off the screen. So using this one class, we've managed to reduce the amount of code that we had when we had 2 balls to begin with. We can reduce it even further. I spoke about wanting about 200 different balls. You know, a few hundred, a few thousand. We want to be able to have any number of them. So what we're going to do, instead of declaring individual objects, just like our other data types, we can make arrays. And what a sensible name for the plural of person. I'm going to call my array people. And I'm going to set it up to a particular size, because that's what we have to do before we use an array. We have to give it an initial size. Let's go with 20 at first, just to test it out, to make sure that it will actually run with 20 rather than any more. And it means that we'll have to change some of the code that we had before, because we no longer have P1, P2. Instead, we've got this array of 20 people. So we're going to have a for loop that will go through the length of the array. And it's going to make a person for each position in that array. So people position I equals new person, and again sending in the height and the width of the form, so it knows where it can randomly create it. So now this for loop is going through and making, because we know the length of the array is 20, it would make 20 instances of the class person, placing them in our array of people. We can use this for loop again and again and again to go through this array. But I do want to show you a slightly different type of for loop called a for each. So I've got rid of the 2 individual people and drawing them, and instead I'm going to use a for each loop to go through my new person array. So I'm going to have a person called P inside of people. So what this will do, it'll take the first object inside of people and put it as P. So I can say P dot draw person, sending in the graphics. P dot draw person. So for every person in that people array, in the array of person, it will get the person, draw them, and that's how you're going to draw all 20. It's going to go through this loop the 20 times, taking out each person individually and then doing the code to draw them. And it will be drawing that instance of the person. And then I want to do a similar thing in the timer tick to move the person around. So again, the for each, in fact, we could just copy and paste. Copy, paste. But instead of drawing, we want to move them here. And we'll need that client width, client height again, so that we don't let the people move outside the boundaries of the form. Again, it just goes through the array of people and then gets a person out, moves a person, and it's going to do that for all, in this case 20 at the moment, but for any number that are in the array, go through and move them all, invalidate, So force the form to redraw. When the form redraws, it's going to call this subroutine, and then for each of the people in the people array, it's going to go and draw them. So when I run the code now, we should be expecting 20 blue circles to all be flying around our form. And we cross our fingers, and because they're moving, it's going to be pretty hard to count, but it looks to be about 20. I trust my coding that it definitely is. And you can see that they've got some sorts of random movements to them, and that they were clearly drawn initially in different places. So you can see how using a class and creating objects out of that class ends up being a lot quicker to code multiple things, to be able to reuse the code over and over again. And to be able to increase the amount. So if we go for 200 now, all I've had to do is change that one value, not had to do any additional coding now, and I'm going to have gone up from 20 to 200 different people flying around my form. Again, we can keep pushing this. See if 2000 would look, what 2000 would look like. By using this class and creating objects out of this class, adding extreme amounts to my form can just be the case of changing one number. It's still working relatively smoothly. Really push it up now. 20,000. We should start to see some sort of performance lagging. Some sort of frame rate drop. Because it's having to deal with so many more. There we go. It's having to process so many more now. It's not managing to keep up. But you can see that we can still get an extreme amount of objects on the screen at once, just by changing one figure rather than changing multiple lines of code. So hopefully you're seeing that using object-oriented programming encourages good practices, makes your life a lot easier. Coding becomes a lot easier to do. Changes to the code that you want to make, adding additional objects, it becomes so easy. For now, we'll probably revert back to it being 200 people, and we've got our basic area. We want to do a few upgrades before we really get any disease involved. Like, we want to find out when these are touching each other, so we know when they should infect each other. But for now, that's looking pretty good.